determine which of the given graphs is the graph where the function f of x equals the opposite of the quantity x plus 3 times the quantity x plus 1 times the quantity x minus 1. The point of this question is not to simply graph the given function with technology and then match the graph. The point is to discover some of the characteristics of the given function. Let's begin by determining the intercepts for the given function. Recall to determine the x-intercepts, we set y or f of x equal to 0 and solve for x, which gives us the equation 0 equals the opposite of the quantity x plus 3 times the quantity x plus 1 times the quantity x minus 1. The product on the right is equal to 0 when x equals negative 3, or x equals negative 1, or x equals positive 1. This indicates the x-intercepts are negative 3, 0, negative 1, 0, and 1, 0. However, notice all four graphs have these 3 points as their x-intercepts. And if these are the x-intercepts, recall these zeros are the x values that make the function value equal to 0, and therefore the zeros are x equals negative 3, negative 1, and 1. Notice each of the factors that gave us these zeros is raised to the first power, which means the multiplicity of each of these zeros is equal to 1. If we take a look at the graphs, recall this indicates the graph must cross through the x-axis at the x-intercepts, not touch the x-axis and bounce back. Looking at the graphs on the right, notice the second graph in the first row has a 0 of negative 3, but it doesn't pass through the x-axis. It touches the x-axis and bounces back, which means the 0 of negative 3 has an even multiplicity, and therefore this could not be the correct graph. And the same thing is true for the second graph in the second row. The 0 of negative 1 has an even multiplicity, again because the graph touches the x-axis at negative 1 and then bounces back, indicating the 0 of negative 1 has an even multiplicity, and therefore it can't have a multiplicity of 1. Let's also determine the y-intercept. Recall to determine the y-intercept, we set x equal to 0 and determine y, or determine f of 0. In our case, f of 0 is equal to the opposite of 3 times 1 times negative 1, which is equal to positive 3. The y-intercept is 0, 3. This actually is enough information to select the correct graph. Notice the graph in the second row has a negative y-intercept, not a positive y-intercept, and therefore this graph cannot be correct. But let's also determine the end behavior just to verify this first graph is correct. Recall when determining the end behavior of a polynomial function, we only have to consider the term with the highest degree. If we were to multiply out the factors of f of x, notice the highest degree term would be negative x cubed. We can write f of x as f of x equals negative x cubed, and then we'd have plus additional terms which would not affect the end behavior. And now let's determine the end behavior as x approaches positive infinity. When x approaches positive infinity, x cubed is approaching positive infinity, but then we take the opposite of that value, and therefore f of x is approaching negative infinity. As x approaches infinity, f of x approaches negative infinity. And now let's determine what's happening to f of x as x approaches negative infinity. As x approaches negative infinity, the value is being cubed, which is still negative, but then we're taking the opposite of that value, which makes it positive, which indicates as x approaches negative infinity, f of x approaches positive infinity. And now let's analyze the graph that remains. As x approaches negative infinity, or as we move to the left along the graph, notice the graph goes up, indicating f of x approaches positive infinity. And as x approaches positive infinity, or as we move to the right, notice the graph goes down, and therefore f of x is approaching negative infinity. This graph has the end behavior that we just found, once again verifying this is the correct graph. I hope you found this helpful.